few 12.5 examples. The lesson is on volumes of pyramids and cones. Real quick, the formula for finding the volume of a cone and a pyramid, you should think of those as in the same family, just like C&P flat tops are in the same family. So to find the volume for both, we're going to take 1/3 times the base and the height. That will find us the volume of both of those. So the height of the cone is the perpendicular. If I were to drop a line right down the center, that's my height. And my base is this circle. So it's going to be 1/3 pi r squared times the height. Okay. You should also realize, since it's 1/3, we have seen base times height before. Area of the base times the height is actually the the volume of the cylinder. So you should think that the cone is just 1/3 of that. Cut the volume of a cylinder in thirds, and 1/3 is the cone. That is also the true with the pyramid here. So here my base, in this case, is a quadrilateral. And again, the height is this drop down distance perpendicular to the base. That's my height. And again, just like with the cone, it's 1/3 the base times the height. The area of the base times the height. Now remember, this base might be a triangle. It could be a square, right? It could be a rectangle. Could be a hexagon. So there's lots of different bases that can take on. So you have to pay close attention to that. So that's your formula for all these problems. Now, let's take a look at this, an example like this. A square pyramid has a height of 12 units. So be sure you're clear on what the height is. The height starts from the top and you drop it down, and it's perpendicular. Now I notice that this says square pyramid, so that means all the base is a square. The base edge would be this, is 10. So that's 10, this is 10, along the back is 10, and that's 10, it's a square. So we've got 12 high, and the base is 10 by 10. So it's as easy as it looks. Volume equals 1/3 area of the base times the height. 1/3 10 squared is the area of that base. The area of that base is 10 squared times the height of 12. That is 1/3 times 100 times 12. 12 divided by 3 is 4, so this is 4 times 100, or 400 units units cubed. Okay. Units cubed. How did I get units cubed? Well, remember that that's units squared, and that's just units, and I multiply units squared and units to get units cubed. It does ask for surface area, so just kind of a review, I guess. Remember, the surface area looks like this. It is a 10 by 10 base, and then I've got these triangle. The lateral area is a triangle. What's a little bit tricky about finding this the surface area, no problem with the area of the base. That's 100, 10 by 10. But you do need to find this slant height. That right there is a slant height. So what is that on this picture? It looks like this. It's perpendicular. We need to find that. So we're going to create a triangle. This is the triangle that we're looking at here. It's 12. This is a right triangle, and you should know this leg. That's what you have to be able to see. That leg is 5 because it's half of the entire 10 units. So 5, 12, 5, 12, 13. So that's a 5, 12, 13 triangle. right triangle, so that makes this 13, this 10, and now it's a piece of cake. 1/2 small b times h. Small b is 10, so 1/2 times 10 times 13 is 5 times 13. We're finding area here. And 5 times 13 is 50 plus 15, 65. 65 units squared. So that is the area of just one of these triangles. So to find my total surface area, I'm going to take 100, that's the base, that's the area of the base, and I'm going to add it to 4 times 65. And that's the area that's my lateral area. So this is a little review of surface area. Simplify that and you have your answer. Let's move on. Let's look at another example. A well has a cylindrical wall 50 meters deep. So this is a well, it holds water. So the wall of this cylinder is 50 meters, very deep, and a diameter of 6 meters. So the diameter here is 6 meters. Let's break that into 3 and 3 meters. The tapered bottom forms a cone with a slant height of 5 meters. So this slant height here is 5 meters. Okay. Now you should realize, since cylinder is a CMP flat top, this circle is right here as well, and that distance is that radius is 3. So we break this into two parts, right? If I'm going to find my volume, I'm going to find the volume of the cylinder, which is area of the base times height, which is pi times the radius squared times the height of 50 meters, and that is going to be 9 times 50. 9 times 50 is 450 pi meters cubed. Okay? Alright, so I found that. Now I'm going to find the cone. I'm going to just take it in two parts here. So I'm going to find the volume of the cone, which is 1/3 the area of the base times height. It's always nice to write your formula out first and then fill it in. It's a nice skill to have, especially in the sciences, physics and chemistry. Area of the base is pi times r squared. We already found that. Multiply it by the height. Now remember, this is the height of the cone. Looks like that's going to be what we need to find, is the height of this cone. This is a slant height. 5 is slant height, 3 is a radius, and this is a 3, 4, 5 triangle. So this is 1/3 times pi times 3 squared times 4. That's 1/3 times pi times 9 times 4. I'm going to simplify a third into 9, which is 3. So I've got 4. We've got 3. 1/3 of 9 is 3, so 3 times 4 pi, which is 12 pi. In this case, it's meters cubed. I'm going to take that and add it to this to get a total of 462 pi meters cubed. All right. There's an example where you have to put it and take it apart and work each part and then put it together. You had to solve for the height of the cone. So you need to be keeping your Pythagorean triples in view. And let's look at another example here, which is really the same kind of concept. We've got a hexagonal prism, that's on bottom, and then a pyramid hexagonal um, on top there. Okay. All right. Um, let's look at, let's work each of these out separately. So I'm going to work out my hexagonal prism. We're going to find the volume of that first, which we know to be the area of the base times the height. All right. How do I find the area of the base of the hexagon? Okay, well this is a regular hexagon. I'm going to find my center. There's my center point. Remember, we need to break this up and find its apothem. It's 1/2 the apothem times perimeter. That is the area of my base, and then I'll multiply it by a height, and I'll have volume. Well, the apothem is this distance here. Okay, let me recenter that. Didn't spell hexagon right. It's an A. Sorry. All right. So this center, you kind of have to see this 3 dimensions. Sorry. This is my apothem. It's perpendicular, and it divides that into 2 parts, 5 by 5. I want to know that distance there. Well, remember this triangle here has a measure of 60 degrees because 360 divided by 6 is 60 degrees. That leaves this a 30-degree angle. So that makes this 60 degrees, right? So 30, 60, 90. So this is my short leg. That makes my hypotenuse 10, and it makes my my long leg 5√3. All right, so I can now find my apothem is 5√3. My perimeter is 60, and my height is 10. So I've got 30 times 5, I'm simplifying that, times 5 times 10 is 1,500√3. Check my work there. 10 times 60 is 600. I'll multiply that by 5, divide that by 2, 1,500, yep. And that is units cubed. So that's my hexagonal prism. And now we'll find the volume of the pyramid. Okay, volume of the pyramid is 1/3 the area of the base times height. Now what's nice is I have already found the area of the base. So let's just plug that in. The area of the base, where was it? It was right here. We already found that. So always use what you've already found there. So that's 30 times 5, 150. 150√3. Okay, and now I need to hunt for my height. Okay, height. Now, put your thinking cap on here. This is the height that I'm referring to, and it's perpendicular to that base. Now, I'm given here that the edge is 20, so I want you to look at this triangle. This is a right triangle. It's in 3 dimensions. So this is 20, and we know this distance here. This distance, we have already found that distance. It's right here, and it's that unit. That distance is 10. And now, Pythagorean theorem allows us to find height. Height squared plus 10 squared equals 20 squared. Height squared equals 20 squared minus 10 squared equals 400 minus 100 equals 300. h squared equals 300. So that is going to be, when I square root that, I've got 100 times 3, or 10 root 3. Okay. 10 root 3 is my height. So now I can finish this. 1/3 times 150 root 3. Multiply that by 10 root 3. So I've got 10 times 150. Divide that all by 3. That gives me 500. Multiply, I've got a root 3 times root 3. It's just 3. So 1500. Isn't that interesting? Comes out with the same volume. Units cubed. I'm going to add 1500 with 1500 to get my total. Total volume equals 1500 for the hexagonal prism, plus 1500 for the other is 3000 units cubed. Alright, so there you have a couple examples of finding volumes of pyramids and cones and applying those. So, alright, that should give you a little bit of help, I think, when you go into your homework. Thank you.